Find the antiderivative of g of x equals x plus 1 over x. This is a little bit different from the last example because here we have the sum of two functions, two simple functions. And remember that when we differentiate the sum or difference of functions, we take those derivatives separately. We add or subtract the derivatives of those functions. And the same thing works when we're looking at antiderivatives. We can do them one term at a time. So we can start with the antiderivative of x and then get the antiderivative of 1 plus x. So we've got capital G of x equals. We start with the derivative of x, and we actually can use a rule that we just saw. We saw a rule that says if we have a function that's x to a power, so long as that power isn't -1, then the antiderivative we get by adding 1 to the power, which would make it x squared, and then dividing by the new power. So that's going to be x squared over 2. That is the power rule for antiderivatives. And we could check if we differentiate this, the derivative of x squared is 2x, and 2x divided by 2 just gives us that x. So that's good for that term. And then plus, do you remember the antiderivative for 1 over x? If not, can you think of a function that gives us a derivative of 1 over x? Hopefully you remember that ln of x gives us a derivative of 1 over x. But maybe even better, you remember that the antiderivative of 1 over x is ln of the absolute value of x. And that's because of the domain. This is something that we looked at before. It's also a rule. And so we have x squared over 2 plus ln of the absolute value of x. Now we still have to think about that arbitrary constant. And you might be wondering, do we need to add one constant for x squared over 2 and another for ln of the absolute value of x? Right, we looked at these two antiderivatives separately. We did it term by term. And so kind of theoretically, both of those give us a constant. But we don't actually have to deal with two constants, because if we did, if we had one of the constants be c1 and one of them be c2, and we add them together, one constant plus another constant is just a third constant. And so in a case like this, we don't need two constant terms. We just need the one. So this is going to be x squared over 2 plus ln of the absolute value of x plus c.